Math in the house. Today, we're doing math analysis, chapter 5, section 2, the sum and difference identity. I'm your host, Dr. D. Okay, does sine of A plus B equal sine of A plus sine of B? No! Does cosine of A plus B equal cosine of A plus cosine of B? No! Does tangent of A plus B equal tangent of A plus tangent of B? No! Okay, that's enough out of you. Okay. No, these are not true. But we do have identities called the sum and difference identities that will tell us what sine of A plus B equals. So here it is. Sine of A plus B equals sine of A cosine of B plus sine of B cosine of A. And sine of A minus B equals sine of A cosine of B minus sine of B cosine of A. Now, that looks really complicated, but it really isn't that complicated. First thing, the sines. You're just going sine, cosine, and then sine, cosine, trade partners. And if it's plus here, it's plus here. If it's minus here, it's minus here. So that's all you have to remember is you're going sine, cosine, trade partners. Same sign. Now, cosine of A plus B. This is cosine, cosine minus sine, sine. So first thing you notice is instead of sine, cosine, it's cosine, cosine, sine, sine. Second thing you notice is if it's a plus here, it's a minus here. And if it's a minus here, it's a plus here. So we have the opposite sign. Okay, now tangent is tangent of A plus B equals tangent A plus tangent B over 1 minus tangent A tangent B. So notice the top has the same sign and the bottom has the opposite sign. So if it's tangent of A minus B, we have tangent A minus tangent B over 1 plus tangent A tangent B. Now, here's a couple of ways I use to remember the tangent. First of all, tangent is sine over cosine. And sine is the same sign, cosine is the opposite sign. So that's what we're doing. Same sign on top, opposite sign on the bottom. The other thing that I use to remember is tangent of A plus B equals tangent A plus tangent B. That's what we wish it was. You know, it'd be really handy if tangent A plus B equaled tangent A plus tangent B. So that's what the top is what we wish it was, and then the bottom makes it all confusing. So that's the key thing. You just have to memorize these three identities. They're called the sum and difference identities. And there is no substitute for plain knowing this stuff. Okay, so let's try some example problems with them. So sine 25 degrees times cosine 35 degrees plus sine 35 degrees times cosine 25 degrees. Now, the key thing there is you should see that this is an identity. Sine cosine plus sine cosine. And notice what happens. The 35 and the 25 change partners. So this whole thing then equals sine of 25 plus 35. Okay? Sine of A plus B equals sine A cosine B plus sine B cosine A. All right, so this equals sine of 60 degrees. How convenient! Sine of 60 degrees. Here's my 60 degrees. What's the sine of that? Opposite over hypotenuse. Square root of 3 over 2. Bam, that's it, game over. And notice if we hadn't known this identity here, there's no way we know what sine of 25 is and cosine of 35 is without a calculator. So this is a way of knowing how to do it with no calculator. Okay. We have a similar situation here. Where have we ever seen cosine cosine plus sine sine? That seems like we've seen it somewhere before. Cosine cosine plus sine sine. So notice that's cosine A minus B. All right, so this whole thing then equals cosine of A minus B. Remember, cosine is opposite signs. And so now that equals cosine of, well, remember, pi over 6 minus, now pi over 3 is 2 pi over 6. So that equals negative pi over 6. So I have cosine of negative pi over 6. Now, there's a couple ways we could do this. One way is we could say, well, where's negative pi over 6? It's pi over 6 in the clockwise direction. And so what's the cosine of this angle? Well, it's adjacent over hypotenuse, square root of 3 over 2. The other way we could do it, so here's my negative pi over 6. So the other way we could do it is to say that cosine of negative x equals cosine of x. In other words, cosine of negative pi over 6 equals cosine of positive pi over 6. And you know cosine of positive pi over 6, that's right up here. And so you know it's going to be square root of 3 over 2 also. So we got square root of 3 over 2 any way you slice it. So that's it. Game over. Okay, next problem, sine of negative 75 degrees. Now what we need to do is we need to find a sum or difference of angles that adds to negative 75. So one set of angles that I could think of is 225 minus 150. Now 225 minus 150 is 75 degrees. So that means if we want a negative 75, we need to go 150 minus 225. So sine of negative 75 equals sine of 150 minus 225. Okay, so we just go sine, cosine, and then same sign, trade dance partners, sine, cosine. All right, so now what we have to do is figure out what the sine and cosine of these angles are. So let's look at the 150 degree angle. That's right here. Sine is going to be 1/2. cosine is going to be negative square root of 3 over 2. Then when we look at our 225 degree angle, sine is negative square root of 2 over 2. And cosine is negative square root of 2 over 2. Okay, so let's plug in those values. Sine of 150, 1/2. Cosine 225, negative square root of 2 over 2. Sine of 225, negative square root of 2 over 2. Cosine of 150, negative square root of 3 over 2. All right, so negative times negative makes this a positive. So it's going to be negative square root of 2 over 4 minus square root of 6 over 4. So the final answer is going to be negative square root of 2 minus square root of 6, all divided by 4. Now you can check that out on your calculator. Just punch out sine of 75, sine of negative 75, and then punch out negative square root of 2 minus square root of 6, divide the whole thing by 4, and you'll find out that they are indeed equal. Okay, cruising onward. What about cosine 11 pi over 12? Oh yeah, this just gives you a little tinkle. All right, so we need to figure out what fractions add up to 11/12. So notice what we need is the 12ths. So basically, pi over 6 equals 2 pi over 12. Pi over 4 equals 3 pi over 12. Pi over 3 equals 4 pi over 12. So then pi over 2 equals 6 pi over 12. Now I don't have any 2 of these that I can add up to get 11 yet. So we need to keep going. So if we keep going around the unit circle, we have 2 pi over 3, which equals 8 pi over 12. Now, notice 8 plus 3 is 11. So that's what we needed. Now, if we keep going, we could find a difference that will come down to 11 pi over 12. Like if I go to, let's see, 14, yeah, 14 pi over 12 minus 3 pi over 12 is 11 pi over 12. And 14 pi over 12 is 7 pi over 6, which we know the sine and cosine of that. So, but we'll take the easy way and do the plus. So 8 plus 3 is 11. So we'll just write this out. This is cosine of 2 pi over 3 plus pi over 4. Okay, so this equals cosine, opposite sign, so minus sine, sine. Okay, so now all we have to do is figure out what sine and cosine of these angles are. So here's my pi over 4. So I know that sine and cosine of this angle are both going to be square root 2 over 2. And 2 pi over 3 is up here. So sine is square root 3 over 2, and cosine is negative 1/2. So let's plug those in. So cosine 2 pi over 3, negative 1/2 times cosine pi over 4, square root 2 over 2, minus sine 2 pi over 3, which is positive square root 3 over 2, times sine pi over 4, which is square root 2 over 2. So this is going to equal negative square root 2 minus square root 6 all over 4. So notice cosine of 11 pi over 12 and sine of negative 75 degrees are the same thing. They're basically complementary angles if you were to change the radians into degrees or vice versa. Okay, cruising onward. Tangent pi over 12. Ooh, yeah. Okay, we have another situation where we need to look at the angles that we know and see if we can make a pi over 12. So notice, well, if we go back to this situation here, pi over 12, I'm going to need to find two values that are 1 apart. 3 pi over 12, 4 pi over 12. So if I go 4 pi over 12 minus 1 pi over 12, or 4 pi over 12 minus 3 pi over 12, that gives me pi over 12. So that's what I have here, is this is going to be tangent of pi over 3 minus pi over 4. Okay, so what's the tangent function? It's what we wish it was, tangent pi over 3 minus tangent pi over 4, all over 1 opposite sign now plus tangent pi over 3 tangent pi over 4. Okay, so now what we have to do is figure out what tangent pi over 3 and tangent pi over 4 is. Well, here's pi over 3, and tangent is square root of 3 over 1. And here's pi over 4, and tangent is 1. So this thing becomes square root of 3 minus 1 over 1 plus square root of 3 times 1. Now, just for simplicity, let's change the bottom to square root of 3 plus 1. Okay, now, we are not like the godless heathen who leave radicals in the denominator. So what we need to do is get rid of the square root of 3 in the denominator. So to do that, we need to multiply by the conjugate. So I have square root of 3 minus 1 over square root of 3 plus 1, and I'm going to multiply by square root of 3 minus 1 over square root of 3 minus 1. So notice what happens here then is on the bottom I have a plus b times a minus b, which is a squared minus b squared. And on top I have a minus b times a minus b, which is a squared minus 2ab plus b squared. Okay, so this whole thing turns out to be 3 plus 1 is 4 minus 2 square root of 3 all over 2. And I can cancel a 2 out of all three things, or I can make this 4 over 2, which is 2, minus 2 square root of 3 over 2, which is just square root of 3. So this is your final answer, 2 minus square root of 3. Now remember, you can always check that by going to your calculator and going tangent pi over 12 is 2 minus square root of 3. And even without a calculator, you can see that that's going to end up being pretty close, because pi over 6 is a 30-degree angle. So pi over 12 would be a 15-degree angle. Now tangent is opposite over adjacent. So that's going to be a fairly small number. Well, 2 is the square root of 4, and square root of 4 minus square root of 3 is a small number. So that's going to confirm it roughly. But your calculator will confirm it exactly. Okay, now, the next game we're playing here is we're given that sine of alpha is negative 3/5, and the terminal side of alpha is in quadrant 4. And then cosine of beta is 5/13, and the terminal side of beta is in quadrant 1. And we want tangent of alpha plus beta. Well, let's first of all look, what is tangent of alpha plus beta? Well, it's tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. That's just our identity. And now we need to know what tangent alpha and tangent beta are. Well, if we're given that sine of alpha is negative 3/5, and the terminal side's in quadrant 4, so the opposite is negative 3, and the hypotenuse is 5. So what's our third side? Well, it's 25 minus 9, which is 16. Square root of 16 is 4. And that's going to be a positive 4. Now notice they had to tell us this in quadrant 4 because we could have the sine of alpha being negative also in quadrant 3. Notice if this was negative 3 and this was 5, sine of alpha is still negative 3/5. But notice the cosine would be negative 4/5, whereas cosine here is positive 4/5. Okay, so, or actually more importantly, the tangent is negative 3/4, whereas tangent here would be positive 3/4. Okay, so we'll get rid of this thing. So this is our alpha angle. Let's just put alpha there. So that's our alpha angle. Now our beta angle says cosine is 5/13 and terminal sides in quadrant 1. So let's go to the beta angle. 5/13 means adjacent over hypotenuse is 5/13. Now what's the opposite side? Well, 169 minus 25 is 144. Or you remember your Pythagorean triple 5, 12, 13. So now I could get the tangent of beta. So tangent of alpha is negative 3/4 plus tangent of beta 12/5 over 1 minus negative 3/4 times 12/5. Okay, so we need a common denominator for the top, and that's going to be 20. So that's going to be negative 15 20ths plus 48 20ths. And the bottom is going to be 1 minus a negative, which means 1 plus 3 times 12 is 36 over 20. Okay, so 48 minus 15 is 33. So the whole thing equals 33 20ths over. Now, let's just turn this into 20ths also. So 20 over 20 plus 36 over 20 is 56 over 20. So now if we flip the bottom and multiply, you can see it's going to be 33 over 56. Can we reduce that? Well, 33 is 3 times 11. 56 is 7 times 8, which is 7 times 2 times 2 times 2. So there are no matches. So 33 and 56 are mutually prime. So that means tangent of alpha plus beta equals 33 over 56. So basically, when you're given the sine of an angle, then you could get the cosine, the tangent, the secant, the cosecant, the cotangent of that angle. And if you're given cosine of an angle, you can get all the other trig functions too. And now once I have all my trig functions, then I can plug it into any of the identities. Okay, now verify that tangent theta minus pi over 4 equals tangent theta minus 1 over tangent theta plus 1. Okay, well, let's do our trig identity here. So tangent theta minus pi over 4 equals tangent theta minus tangent pi over 4 over 1 plus tangent theta tangent pi over 4. Well, this is kind of nice because you know that tangent pi over 4 is 1, right? So that means this is tangent theta minus 1 over, now tangent theta times 1 is 1 plus tangent theta, or tangent theta plus 1. That's it. QED, game over. Okay. One more. We want to verify that sine A plus B times sine A minus B equals sine squared A minus sine squared B. Okay, so let's check that out. Sine of A plus B equals sine A cosine B plus sine B cosine A. Now we need to multiply that by sine of A minus B. So that's going to be sine A cosine B minus sine B cosine A. Notice all we did was go sine cosine, then trade partners, sine cosine, and keep the same sign. All right, so when we FOIL this, we get sine A cosine B times sine A cosine B, which is sine squared A cosine squared B. Now, we're going to go plus, well, no, let's stick with this one, minus sine A sine B cosine B cosine A. So minus sine A sine B cosine A cosine B. Okay, now we go the two inner ones now. So it's going to be plus sine A sine B cosine A cosine B. So notice those two middle terms are going to cancel. And now I have the two end terms, sine B, cosine A, cosine A. And notice there's a minus here. So it's going to be minus sine squared B cosine squared A. So, like I said, the two middle terms cancel, and I'm left with sine squared A cosine squared B minus sine squared B cosine squared A. Now, notice what we're trying to get to is right here. So we need to get all sines here. So what we're going to do is change all the cosines into sines. So that means we go sine squared A times 1 minus sine squared B. And then we have minus sine squared B times 1 minus sine squared A. Because sine squared plus cosine squared equals 1, so cosine squared equals 1 minus sine squared. So that's all I did for both of the cosine squareds. Now all I do is distribute this, so I have sine squared A minus sine squared A sine squared B, then minus sine squared B, oh, I forgot to put a B here, minus sine squared B. Now minus times minus is plus sine squared A sine squared B. So notice we have a minus sine squared A sine squared B plus sine squared A sine squared B. So that means we end up with just sine squared A minus sine squared B. That's it. QED. Game over. Now, one thing I want to point out is in verifying these identities, sometimes you're going to think all is lost, you've made a wrong turn at Albuquerque and it's a giant mess, and you want to quit. But this is kind of like a metaphor of the Christian walk. You know, so often we think everything's going wrong, but God promises in Romans 8:28 that all things work together for good to those who love the Lord and are called according to his purpose. So you think everything's a giant mess, but then it all works out in the end. That's it. Have fun with these.